third lecture or lesson or whatever. Let's go. So last time we looked at variables, and this time we're gonna, let's close this, reopen it again. Let's go to terminal and let's look at, let's make it a bit bigger. Let's open Python and let's look at variables and again, and what we can store in variables, right? The main idea here, like if I call x from like the previous code that we wrote, what you will see is, first of all, you're gonna get a name error again, right? The reason because is that I closed the terminal and reopened the terminal again. So what happened was that I had a new instance of Python shell coming up. And so when this happens, because the values that I'm coding here are saved in the memory, right? If I call them again after I rerun it, it's going to be gone because the memory doesn't remember anything. It doesn't save it there. And so when I call x again, I have to define x. So here I'm going to say x is equal to 2, for example, and then I'm going to use it. To demonstrate what's going on this time in this lesson, I'm going to introduce a new command called type. And so when I say type bracket x bracket closed, and I press enter, it gives me what type is stored inside of this variable. We have different types because different types inside of a variable can take different amounts of memory, and so the computer has to know how big it is, and also because different types of data have different functionalities. Like for example, you can increment numbers. You can add 1 to a numeric value, but you can't add 1 to a text, right? Or I don't know, for a text, you can go through all the elements or whatever and see what each letter is. You can't do that with numbers, or you can't set numbers to be uppercase or lowercase, but you can't do that with text. So the types are different, so the computer has to be able to distinguish them so that we can do different operations with them, and this helps us, right? So the first thing we have to look at is the type. So here, if you look at the type, it says class and then int in quotations. And we're going to not care about the class for now. What we're going to look at is the int. And int stands for integer. It's a simple numeric value that shows you that this is a number that's saved inside of x. And so if I do y is equal to 12 divided by 4, if I see what y is 3.0. And this is different than the value in x, right? Because x didn't have a decimal, but y had a decimal place. And so to check the type, if I say what the type of y is, what I'm going to get is a class float. And so floats are numbers with decimals, basically. And that's the main difference, right? Because if you have decimals in a number, you're going to have a different type of storage and a different amount of memory that's going to have to be access to store this value, right? Because decimals are different. And the reason the division operation always has a decimal on it is because when you do division, usually you always get some decimal places afterwards. Like for example, if I do 21 divided by 6, I get 3.5, and the 0.5 is a decimal that is inside of the value, and I have to show it and represent it. If I don't want that, what I can always do is I can say 21 divided by, and I'm going to put the slash sign twice. I don't know if it's a slash or backslash, whatever. If I put this twice and I say this divided by 6, I get 3. And what it does is it does the computation, and then it cuts the decimal place and it rounds it down to the nearest number that there is. And so now if I check the type of this again, I'm going to see if I check the type of 21 divided by 6, I get an integer, right? Because this operation rounds it down to the nearest integer. And that is basically the two numeric values that Python usually holds. In other programming languages, there are other values that they can hold and other types of numbers, but we don't really care about them for now. And we only want to know the difference between integers and floats. Integers are regular numbers. Floats have decimal points and decimal places. That's basically it. Okay, what else do we have? Let's say, what if I don't want to save a number? I want to save a name. Like for example, my name is Ali. I want to save that to a variable. What do I do? So if I say name is the name of my variable, and I'm going to say name is equal to, and I want to put my personal name inside of that variable position. If I say Ali, for example, right? If I press enter, what you see as a name error. And the computer says Ali is not defined, right? What this means is that right now the computer thinks that Ali is the name of a variable, and it wants to save whatever is in that variable name into the variable name, right? Like if I want to show something similar, is like x is equal to 2 right now, right? If I say y is equal to x, and I see what y is also 2 now, right? Because whatever was in x has now been put in y, and now y has the same value as well, right? The computer was thinking when I said name is equal to Ali, it was something similar that I was doing, and Ali was not defined, so it was like, hey, wait a minute, you've never defined Ali before. And so programmers back in the day had to find a way to distinguish text from variable names. And so what they did was they said name is equal to, instead of writing the name as it is, we're going to put it in single quotes or double quotes. So I'm going to say name is equal to Ali, and then now I press enter, it accepts it, and if I ask what the name is, it's going to show me that name is Ali. But what is the type of name? Okay, let's look at the type of name, and the type of name here is a class str. Str stands for string, right? This is a string of text, basically, and that's how the computer looks at strings, and it processes it there. Okay, and that's the third data type we're going to learn. And the last thing that we're going to also learn is booleans. The idea of boolean is an important variable in computers because we do a lot of processes with booleans that the computer checks, and we use it in a lot of different places, right? A common example is if I say, is 5, this is another operation that we can do with computers, is 5 bigger than 3? Is 5 bigger than 3? Yes, it is. And so it gives me true. If I say, okay, what about 2? Is 2 bigger than 3? And 2 is false, because 2 is smaller than 3. And true-false values are basically called booleans in Python. If I have a variable a and I say a is equal to true, if I look at the type of a, you will see that it's a type boolean. And booleans are logical variables, right? Like you can have true, false. It can be 0 and 1. And that's basically the idea. And we always can do these comparisons and get boolean values in return. What I can do is I can say variable b is equal to, I'm gonna put it in brackets. I'm gonna be like, is 6 equals 6, right? In Python, if you put one equal sign, it means that you're assigning something to another variable. So if you want to check if two things are equal, we put 2 equal signs, just to be able to differentiate it. And if I do this and I see what b is, because 6 is equal to 6, b has to be true, and b is true. But if I say, okay, c is going to be, let's say, is 6 equals 5, and 6 is not equals 5, so it's going to be false, and it is false, right? And so these basic operations here, we call them Boolean operations. You don't really need to know the name, but basically you return Boolean values for us, and they help us to be able to do some logical operations that we're going to look into in the future when we talk about if statements and whatever. Okay? Yeah, that's basically all. So we have 4 types of values. We have integers, numbers, floats that are numbers with decimals. We have, strings. Strings are text. Anything is a string. Like any text that you have, like whatever writing you have is a string. And then you also have booleans, which are zeros and ones and are basically binary, because computers work with binary, right? And the reason we have binary in computers is because we have electricity in there, and electricity can have 2 states. It can be off and it can be on, right? Off, on, 0, 1, 0, 1, true, false, true, false, true, false. Same thing, right? And that's basically it. In the next lecture, we're going to look at a coding in VS Code, and I'm going to look at a basic if statement to see what is happening there. And I hope you enjoy it. I'll see you in the next video.